Now we will start with chapter 32, electrostatic. Now, let's start talk about the electrical forces and charges. Now, all of us know that there's an atom. Okay, here you have an atom. Sorry. And in an atom, we have a protons, we have an electrons, and we have a neutrons. The protons are positive, the electrons are negative, and the neutrons has non-charged. Now, these are, we call them, so we say that the proton is positively charged. The electron is negatively charged. So what is the charge? And what is the forces between these two charges? Let's see today. Here now, this is, all of us know that there's a force acting between a positive and negative charge. This force, we called it an electrical force. So between any two charges, one is positive and one is negative, there's an electrical, before that, there's a force. Before name it, there's a force. And between two negative charges, there's a force. And between two positive charges, there's a force. These forces now have a magnitude billions upon billions. It's a very, very greater magnitude. The forces here between the two atoms, or the two electrons, or the two proton and electron here, are very, very, very huge. Now, this force is called an electrical forces. Like we have in physics, like we have normal forces, we have gravitational forces, we have frictional forces. Also here we have electrical forces. The electrical forces is a force, there's a force that happens between a pair of electrons or protons, or electron and a proton. Now, all of us know that before in grade 10, we said that if you are standing on Earth, the only force that's acting on you is the gravitational force. You can say it is yes, but there's another two forces. These two forces, it is have a magnitude that is that's stronger than the gravity. It's billion upon billions stronger than the gravity. There's a huge force acting on you upward, but there's another huge force acting on you downward. Since the two forces balance each other, they give only a small force acting on me, which is the gravity. So here, as you see here, you are here on the Earth. Here now, there's a force that's acting on you, which is the gravitational force, and we know what is the gravitational force. But also, there's an electrical, a billion of electrical forces. This electrical force that's between you and the Earth. And also, there's another electrical forces here in the bottom here, or downward. Since they are very huge, and as an example, if this is 1.6 times 10 raised to the power 9, and there's another one 1.6 times 10 raised to the power 9, and there's a gravitational force which is only 9.8. So if you want to draw the free body diagram, that's right, show all the forces acting on you, you will say that there's an electrical forces upward, there's another electrical forces downward, and there's a gravitational force. But these two electrical forces they balance each other, they cancel each other. So only the force that's acting on you is the gravitational force. So consider now a force acting on you that is billions upon billions of times stronger than the gravity. Suppose that in addition to this enormous force, there's a repelling force, also billions upon billions of times stronger than the gravity. The two forces acting on you would balance each other and have no noticeable effect at all. So a pair of such forces acting on you all the time So a pair of such forces acted. I'm sorry. So a pair of such forces acts on you all the time are the electrical forces. So as we see here there's an enormous attractive and repulsive electrical forces between the charge in Earth and the charge in your body. As you know, we have a charge in our body, we have a charge in our Earth. There's an electrical repelling. Now, the electrical repelling forces, it happens between two, later on we will talk about them, between two charge that they are the same. We call them repelling forces. And the attracting forces, it happens between two different forces. So there's an enormous attractive electrical forces between the Earth and you, between the Earth and you. And there's another electrical repelling forces between the Earth and you. Now, they are balancing each other. They are canceling each other. So it's leaving the gravitational or a weaker force acting or affecting on you, which is only the gravitational force. Now, let's talk about the atom. Now, as I told you, inside an atom, we have a proton, electron, and neutron. And there's a force. This force arises from the particles in atoms. We call it electrical forces. So, the electrical forces arise from particles in atoms. Now, there's a protons, electrons, and neutrons. The protons in the nucleus attract the electrons and hold them in orbit. So, the protons So the protons here, the protons attract the electrons, and the electrons attract to protons, but the electrons repel other electrons. So between the electron and the proton, they are attracted to each other like this. They are attracted to each other. The proton with an electron. But for the electrons, electron with electron, they are repelling to each other. One they hold them in the orbit. They are repelling to each other. They have a huge distance between them. So we say, because of that, we will say that between the two same electrons, there's a repel, and between different, or you can say like this, between different electrons, they are attract. to each other. So the fundamental electrical property to which the mutual attraction or repulsion between electrons or protons is attributed, we call it as a charge. So what is the charge? It is electrical property. They say that let's assume that there's a charge, and if the charge is not existed, I will not put in my hand a charge, but there's an electrical property. We have an repulsive and attractive attribution happen between the electrons and the protons. Now, so because of that, I will say that the electrons are negatively charged and the protons are positively charged. But the neutrons have no charge, and they are neither attracted nor repelled by charged particles. So we have protons, neutrons, and electrons. By convention, they are charged. The proton, it will be positively charged. The electron, it will be negatively charged, but the neutron, it will have no charge. Now, and this atom here, this is an atom of helium. This is an atom of helium. It contains, all of know, it has He. I hate chemistry, by the way. It is He plus 2, I think. Okay, it is helium composed of 2 protons and 2 neutrons. The positively charged protons attract 2 negative electrons. It has 2 electrons. These 2 electrons attract with 2 protons. Now, here are some important facts about atoms. Every atom has a positively charged nucleus surrounded by negatively charged electrons, as we see here. Every atom, it has a positively atom inside and an electrons are surrounded by negatively charged electrons. So in the center, we have a protons that they are charged with positive or positively charged, and it is surrounded by negatively charged electrons. Now, all electrons are identical. They have the same volume. They have the same mass. So all electrons are identical. Now, the nucleus is composed of protons and neutrons. All protons are identical. Similarly, all neutrons are identical. Atoms usually have as many electrons as protons, so the atom has 0 net charge. So let's now come back here. I'll stay here, okay. Now, I will repeat it. We all know that there's an atom. In the atom, we have a nucleus here, which is inside. Inside this nucleus, we have a positive protons with neutron, which is uncharged. And this positive protons, it's surrounded by negatively electrons. Now, all the electrons, which is all the orbit, are identical. All the protons, which is in the center, are also identical. Now, if I told you like, I forget chemistry. As an example, oxygen. How many protons for oxygen? 7? Yeah. 6. Can you tell me the fourth oxygen? Yes, grade 11. How many atoms for oxygen? Are there 6?
Teacher, I think.
8? 8?
Yes.
Well, I remember that we wrote like this. So it is 8, 9, okay. So for the oxygen here, we have 8 electrons. This means that we have 8 electrons so this 8, it means that we have 8 electrons and 8 protons. And since they are attracting to each other, like say positive -8 plus 8. -8 is, that means I have negative 8 electrons that they are negatively charged and 8 protons that they have a positively charged. That means they are like canceling each other, so the atoms has 0 net charge. So the charge for an atom is 0. But if you look inside the atom, you will see that, or inside the oxygen atom, we will have 8 protons that they are positively charged and 8 electrons that they are negatively charged, but the net force here is 0.
Teacher, what about the neutrons?
The neutron net has no charge.
Okay.
The charge is only for the proton and for the neutron, for the electron, sorry. For only the protons and electrons are charged. Now, a proton has nearly 2,000 times the mass of an electron. Yeah, like this is the proton and this is the electron. But its positive charge is equal in magnitude to the negative charge of the electron. So I didn't consider I didn't look at the mass. I only take care about the magnitude of the electrons. The magnitude, in spite that the mass of the proton is greater than the mass of the electron, but the magnitude of the charge of the positive charge of the proton is equal to the electron. Now, attraction and repulsion. This is the last thing that we will talk about it today. Here now, as you see, look at the two green balls here. They are positively charged. Since they are positively charged, so they are repel each other. And look at the red balls now, the two red balls in the third picture here. They have the same charge, minus or negative. So they are repel each other. But if you look at the green with red in the second picture, they have positive with negative. They attract each other. So the fundamental rule of all electrical phenomena is that like charges repel and opposite charges attract. Like charges repel and opposite charges attract.